So here's an example number 6 on page 118. Here is a question similar to example number 3, and if you guys remember, in that one we solved this question by giving back the denominator, the common denominator, to each numerator. And that is one method to solve it, and we're also going to solve this question by rationalizing the denominator. So if you cannot always divide the denominator into the numerator, then rationalizing the denominator will always work. So let's first do this question by the previous method we learned so we can recall it. And in that question, we took the denominator and we gave it back to each numerator. So we're going to do the same thing for this one as well. And this method works really well because we know that 2 will divide root 18 and 12. So this gives me root 9 and this gives me root 6. We can then actually simplify each of them even further. This gives me 3 times 3 minus root 6. Really can't do anything with that. And that ends up becoming our final answer. Okay? So that's a method we've already learned. Now how can we do this question by rationalizing the denominator? So again, the same question. This time, we're going to multiply both numerator and denominator by that common, root 2. What does that do? So denominator does become 2, but in the numerator now you have a binomial. So remember that we have to distribute this to both of them. And remember your multiplication rules. So in this case, the 3 gets multiplied by that invisible 1, so it stays as 3. Root 18 and root 2 multiply and they become root 36. Minus, over here, we will just have root 24. So we multiply the numerator coefficients with numerator coefficients, radicants with radicants, and we do get a little bit more complicated numerator, and we're going to have to simplify that. So root 36 is just a 6, whereas root of 24 we're going to have to simplify. It becomes 4 root 6 over 2. This ends up becoming 18 minus 2 root 6 over 2. Now, we should be able to reduce everything by 2. So every single term here gets reduced by 2. So this becomes a 2, this becomes a 1, this becomes a 1. So our final answer is 9 minus root 6. So exactly the same answer as we got. Over 1 just means we don't have to put it there, right? So 9 minus root 6, both the same answers, 2 different ways of doing that. The advantage of this one is that we can use this for any question. This method will only work if the numbers divide out nicely.